Today we are investigating how we can make water evaporate faster.
Right, Prep4, what is evaporation?
Evaporation is water drying up. When water evaporates, it turns into a gas and rises. Steam! Why should everyone stop laughing?
Not again, Dougie.
Steam is an evaporation. The proper word for steam is water vapour. Cold water will evaporate. It's boiling water that evaporates fastest.
And what temperature does water boil at, William?
100 degrees.
Brilliant.
Water vapour is a gas. We can breathe it.
Now, the first investigation is going to be, does water evaporate in a hot place faster than a cold place? So who can give me any ideas at all how we can do that experiment? Does a hot place evaporate faster than a cold place?
Yeah.
Any ideas at all? Go on, Dougie, what's your idea?
I don't really have one.
Jacob?
It is when it's cold, the clothes dry.
But how can we prove that? What investigation could we do to prove that?
We could put some things on the washing line, and then...
But the washing line's got wind as well. A washing line's got wind as well as being hot. Hairdryers have got wind, and they're hot. So it could be the wind, or it could be just heat. Little clue down there. Go on, Tarley.
You could lie it down flat, and then the sun will be...
So put one in the sun.
One in the down flat.
Or one not in the sun.
Like...
That might take quite a long time. Anything we could do like with this cooker that's handily there that would help us?
Oh, put some clothes on it. I don't know.
Charlie?
Put my clothes on.
Yeah, put the cooker in, put one above the heat and the other one we won't turn on.
To make it a fair test, we pour the same amount of water on each tissue. Drip, drip, drip.
Okay, what else do we do to make it this fair test? Have a look.
It has to be the same size of tissue.
Same size of tissue, yes.
I'm going to turn on this ring.
Okay, Dougie, number 5 will do.
Dun, dun.
Okay, that's great.
And we'll put them on the same time.
Okay, spread them out the same way, otherwise that's not a fair test.
Okay.
Now we're going to watch. How can we tell when the water's evaporated?
Let's steam it.
Oh, we can see the water vapour, the steam coming up.
What if it burns?
Well, it might do if you're not careful. Now we should notice it changing colour, because when it dries it'll go...
It's changing colour.
Oh, it is changing colour. It's drying already, that one. And the one that's wet.
It's not changing colour.
It obviously isn't changing colour.
I think that is changing colour. Whoa.
So what does that prove?
It's drying. It's drying fast.
The heat makes the water
Can we keep it on?
evaporate faster. Yeah. If we leave it on too long, it's going to
Can I turn this one on?
No, Dougie, the whole point is...
Oh, yeah.
One is cold, one is hot. Whoa. What is the one thing that we don't change?
The heat. That is.
Yes, the heat. One must be cold, one must be hot.
So bubbly. One must be cold, one must be hot. But that's not, that bit's not dry.
I know, that's because that bit isn't hot.
This bit, the middle bit's getting hot, but really hot. Drying out. Really? I can smell it.
That's because the middle bit isn't in contact with the ring.
Smell something.
That might. You won't smell the water vapour. You'll smell the tissue starting to burn.
Yeah.
Careful, Tommy.
I can burn it. I can smell something.
Dougie, can you turn it off before it catches fire?
In our second investigation, we are going to squeeze the water out of one and see if it makes a difference in how it evaporates. Squeeze!
And the other one's full of water. So this is the amount of water. That's great, Dougie. Thank you. So put them both on the same time, boys. Put yours on the small ring, Dougie. And the one that... Now, which one's evaporating fastest? This one.
This one.
That one's drying fastest.
Go right in.
So the one with the least amount of water has dried first.
It smells like marshmallows. Marshmallows.
Okay.
They're burning.
And this one is still wet on the edge.
That one's half burnt and that one's fully burnt. No, that one's fully burnt. Because that haven't been put there. Our conclusion is that squeezing out the water makes it evaporate faster. Our next investigation is to find out if wind makes evaporation faster.
So then, could we use a hairdryer to do that? Go on, Dougie.
Yes.
Anyone got any other ideas? Charlie?
No.
Why not?
It's warm.
Yeah. Hairdryers are warm.
Well, can we use the cold one?
Don't interrupt. And they got wind as well. But we could, as you say, Dougie, we could just use a cold hairdryer, which is what we're going to do.
I'm going to turn it on to cold wind.
So this one's got no wind, and this one here has the cold wind. Yeah, it shouldn't do, because we've got to try and shield that one from the wind. Yeah, move it a little bit closer, that's it. Right, 5 minutes gone by, turn the camera on again. It's not that quick, is it, Jacob? So, but this one now has definitely dried, the one with a cold wind. It took 5 minutes, and the one with no wind, or hardly any wind at all, don't you, Jacob, is still soaking wet. So what's our conclusion, Jacob? That
our conclusion is that the one with the cold wind dries exactly 5 minutes, but the other one didn't have hardly any wind at all and hasn't dried yet.
Great, thanks, Jacob.
Our next investigation is about spreading out the tissue and seeing which evaporates faster.
Okay, girls and William, stick them on. That's spread out. That's not. To be a fair test, both of the settings are on number 2.
Come on. This one I'm scrunching.
Okay, the one that's all scrunched up, we've got no evaporation at all. This one, we can see the water vapour coming off.
I can't. I know.
There we are, that one is drying. And the one that's scrunched up
is not doing it.
It's not drying.
What about the underneath of it?
Well, that's a good point. And the underneath. Well, no.
A bit. Mine!
There we are. The clothes that are spread out, the tissue that's spread out.
It's all bubbly.
Is now dry.
Yeah, mine's winning. Bubble.
And the one that's all scrunched up is not dry.
Our conclusion is that spreading out a tissue makes it dry faster.
Thanks, William.
Condensation is the opposite of evaporation. To get condensation, you need water vapour and a cold surface.
Now carefully, don't go too close, put the cold surface over the water vapour.
Water vapour.
And we'll see condensation
Underneath.
appearing on the
I can see
cold milk bottle.
Yeah, the sun.
Just move it closer.
The sun under there. I can see condensation. So can I. Condensation. Yeah, I can.
Right, the camera's not really picking up. Okay, Jasper, I'll hold it because I can go a bit closer to you without burning myself. There we are, look.
Condensation.
We have evaporation, condensation and precipitation, rain. The water cycle. Round and round it goes.
So that could just go on forever?
It will go on forever, yes. As it does on the planet Earth. The water in the sea goes into the clouds, down it comes again.
Wait, drip.
Drip, drip,
Oh, that's warm.
drip.
Drip.
Ow,
Drip.
I'm getting
Drip.
my hand burned now.